negative integers under this root sign, all those numbers other than these kind of numbers will be real numbers. So we will study these real numbers in detail now. All right, real numbers. So in the family of numbers, real numbers are like father of all the numbers. Real numbers are like father of all the numbers. And being a father, real number is having two sons. The name of first son is rational number, and the name of second son is irrational numbers. And again, like a family, as we have started, that real numbers are like father of all the numbers and having two sons, rational numbers and irrational numbers. So now here, if we talk about the first son, rational number, suppose he got married and he get a son named integers. The son of rational number is integers, and I will tell you later there is a specific purpose for making a relation of father and son here between these numbers, because so many questions have been asked in the previous years where they have asked some questions based on this chart only. So this chart which I am making here is very important. So rational number, then there is son integers, and the son of integers is whole numbers, and then there is natural numbers. So up to here the relation of father and son will hold true, and after this stage the type of numbers which I will write here will have their unique identity, like odd numbers, then there are even numbers, then prime numbers, composite numbers, there are twin prime numbers, then there are co-prime numbers, then there are perfect numbers, and finally there are Hardy-Ramanujan numbers. This chart is very important because in previous years so many questions have been asked based on these type of numbers and the relation. So please take care while you note down these type of numbers, and this chart is very useful. Okay, as I told you in the beginning, the first son of real number is rational number. So when he got married, he got a son integers, and the son of integers is whole numbers, and there is a son of whole number which is natural numbers. And then, as I told you, rest of the numbers will have the unique identity. So we will discuss them one by one in detail and their application in your UPSC CSAT exam. Okay, so let's talk something about irrational numbers here. This son of real numbers did not marry, so this son is not having any further lineage. What I mean to say here is these type of numbers have their unique identity, and we will discuss these type of numbers in detail in a separate topic called surds and indices. So we will discuss these numbers in detail there, but I will give you some idea during the discussion of rational numbers so that you can differentiate between these numbers, between rational number and irrational number specifically. Okay, so please note down this chart carefully because this is very useful. And yes, one more thing I want to tell, why I am building a relation of father and son here between these type of numbers up to here, up to the natural numbers. Because first of all, let's see the two sons of rational number and irrational number. These are the two sons of real numbers. What does that mean? It means that all the rational numbers are real numbers and all the irrational numbers are real numbers. But the vice versa is not true. That means all real numbers are not rational number and all real numbers are not irrational numbers. Similarly here, all integers are rational number, but all rational numbers are not integers. And same is true in this case. All the whole numbers are integers, but all the integers are not whole numbers. And same is true in this relationship between whole numbers and natural numbers. Though there is a minute difference between whole number and natural number, just a difference of 0 here. All the natural numbers are whole numbers, but all the whole numbers are natural numbers. So be careful while writing this chart. So I think you must have noted down this chart. So let's begin one by one about these type of numbers. We will start with rational numbers. All right. So rational number. And one thing you must remember here, that from the very beginning, since they have started CSAT in 2011, actually they are focusing more on the definition of the numbers. So if you don't know what is the definition of rational number, what is the definition of integers, what is the definition of all such type of numbers, then there are chances that you will do the mistake in tackling the question in your examination. So here, one by one we will discuss their definition and then we will see some of the examples. So first begin with rational number. Definition here is any number in the form of P by Q, where Q is not equal to 0, is called a rational number. Alright, now we will take this P by Q. What is this P by Q here? Here P, this is a fraction in which P represents the numerator, as you know very well, and Q is the denominator. So as per the definition here, the denominator Q, denominator q cannot be equal to 0. The denominator of a rational number can never be equal to 0. Also, these numerator and denominator p and q should be integers. Only integers can be there. So we will take some example to identify these numbers. Suppose I give you one example here, 4 by 5. So now you must tell me, is this a rational number? So yes, it is a rational number. So yes, it is rational. And the reason is because here q, which is 5, that is denominator, and it is not equal to 0. Similarly, if we take one more example like minus 9 by 11. So again, you can see here in the previous example also that 4 and 5 both are integers. We will discuss integers in detail, but for the time being, you can see that 4 and 5 both are integers, and here the denominator is not equal to 0. The denominator is 5 here. Okay. Now here in this example, minus 9 by 11, minus 9 is an integer, 11 is also an integer, so both numerator and denominator both are integers. So yes, again this is a rational number. So q is equal to 11 and it is not equal to 0. So again this is rational number. Alright, let's take one more example here. Suppose I take 5. So 5, just 5. So if only single number is given to you, we will always consider it as the numerator. And if nothing is written in the denominator, we will take the denominator as 1. So if nothing is written in the denominator, we will always take it as 1. So it is nothing but 5 is equal to 5 by 1. So again this is a rational number. Why? The reason is again because q, the denominator is equal to 1 and it is not equal to 0. Alright, now the next example is 0. So be careful here and be smart to answer the question. 0, is this a rational number? So no doubt in that, 0 is a rational number. Because the reason is again true, same reason is there as was in case of 5. It is not just 0, it is 0 by 1. So we can say this is a rational number. Yes, this is rational. The reason is q is equal to 1 and it is not equal to 0. Alright, we will take some more example here. Root 2 by 7. The denominator is 7 here, which is not equal to 0. But you must be careful about this numerator here. This numerator is not an integer, is not. It is not an integer. It is an irrational number. As I told you, we will discuss irrational numbers also. But for the time being, it is not an integer. And this 7 is an integer, no doubt in that, it is an integer. But still it is not a rational number. The reason is because both numerator and denominator are not integers. Denominator is an integer, but the numerator is not an integer. So that's why this is not rational. This is not rational. Now next example we can take root 3 by root 17. It is very much clear from the previous example also that both numerator and denominator both are not an integer. Not an integer. So that's why this is not a rational number. Though here in both the cases the denominator is not equal to 0, but still they are not rational number, because the definition says both p and q, the numerator and denominator should be an integer. So that's why this number is not a rational number. Okay, then we will take one more example here. 13 upon 0. 13 upon 0. You can see the definition says q should never be equal to 0. And what is q here? It is 0 here. So it is not rational. It is not rational. If it is not rational, then what it is? What kind of number it has become now? If we divide any number by 0, it is in mathematics, it is always not defined. So we cannot define if we divide some number by 0. So this is the fractional form of rational numbers.
राजीव जी,
हाँ भाई, इस बार आना। मेरे ख्याल से एक ट्रायल के लिए तो काफी है इतना है। कल फिर धमाकेदार कर देंगे एक बार, मुझे भेज देना इसको।